Alright, this one here is a 2004 Hyundai Sonata. It has the 2.4 4-cylinder. Got the cover off already. Alright, and on the codes menu, you're going to see I have a, when it loads up, I have the P0320, an engine speed circuit fault, and this actually has a new crank sensor in it from a timing belt job last year. Actually, this code was there last year, but he didn't care, but now with an emissions issue he does, so I'm going to chase it. I want you to notice, because this is part of it, under data, when I start it, this thing's running slow, sorry about that. Okay, when I start it up, I have an RPM signal. If you look at the dash, of course the check engine light, and I have no tach. And the tachometer is part of this circuit, so we'll chase it. Alright, the component I want to check, which is part of the flow chart, it gives you a general description. I won't read the whole thing, but I'll leave it here a little bit so in case someone wants to pause it and read it. But if there's any of you Hyundai guys out there that can tell me why this thing is necessary, that'd be great. Because, I mean, I know it's to detect a coil failure, but if it's misfiring, you know, you can know if a coil's bad. But either way, there's a resistor inside of this component that whenever the coils fire, it detects a voltage drop through it. So we're going to check this thing, and really if you look at the flow chart, it kind of tells me to, I won't scroll through the whole thing, but every test it tells me to do is, it gives me a schematic, and it's telling me to check resistance between, you know, check voltage and then check resistance through the terminal and ground and look for open wires, but they're not giving me really any graph. So if I could graph a brake pulsation on a lab scope, I'd do it. So that's the avenue I'm going to go, and not check individual wires. So I'll go to that component, I'll hook it up, we'll see what we have. Well, here's the wiring diagram for it. Mitchell actually looks like it came straight from Hyundai. It's not really your typical Mitchell wiring diagram, but you can see over here this component is the ignition failure sensor, and you have, you know, fused ignition coming in, and then there's a little resistor right there, and then it comes back out and goes back, and it feeds both coils on the positive side. There's two coils firing two plugs each. So the power is coming through this, and I would assume that when the coil actually fires, so whenever the power transistor, which is built inside the coil, actually grounds the coil to fire it, there's a current flow, and then through this resistor you're going to see a small voltage drop. And then this component is going to see that, and then in turn going to send a signal out to the tachometer, which you can't read here, and back to the ignition signal of the PCM. And the computer actually is firing the transistor, you know, the module part of the coil, you know, from by itself, and I believe it's sending like a 5-volt signal or something to it. So I'm going to graph this stuff, we'll see what we have. Alright, so there's your two ignition coils. One probably sits on top of the plug with one wire going to its companion cylinder, and on the side of the cylinder head kind of looks like a little map sensor or something. That is the ignition failure sensor. So it's 4 wires. Like I said, you have your power, your ground, and you have a signal, or you have a wire coming back out to the coils through that resistor, and then you have the signal that would come back out and go to the tachometer and the computer. So with the key on, I have the key on, I'm back probing the power wire, and you can see I have 12 volts. Now if I go to the ground side, usually if you have a bad ground, you'll actually see voltage on the ground side, but if you really need to see it, we could go to a resistance, and I'm not going to calibrate it, use my previous value. If you want to check the resistance, turn the key off, and I have like 1.2 ohms, so insignificant. No bad ground issue that I'm seeing at this time. So the next step is I'm going to check power coming out of it to the coils, but of course I would have to have power because the car runs. But if I go back to my lab scope, my volts, and I gotta turn the key back on. Give me 1 sec. Alright, so with the key back on, 12 volts coming out, and that wire is the same as this wire here, and the same on the other coil. So that's your feed to the coils. So far my ground and my power coming in and out are good. So I want to see if, when it's running, if I can see this little voltage drop they're talking about. So I'll go start it up. I'll be right back. Alright, with it running, you can see I have that little shark tooth looking thing running through there. It's maybe a 1 or 2 volt swing, but I'm assuming that is what they want to see on the coil supply side. When every time the coil fires, when current flows through that resistor, voltage is going to drop a little bit, so you're seeing all the coils drop. So excuse me, just for my own, I don't know, internal knowledge, it might stall, but I'm gonna try disconnecting a coil and see if 2 of those go away. If I can, Alright, so when I make it misfire, I'm running on 2 cylinders. You can see the, I'll pause this. You can see I have like a 60 millisecond gap between, so that's probably that one coil firing, and the gap is longer. So I'll plug it back in and then I'll freeze it again. We'll see where we're at. Plug it back in, car is running smoother again. We will play this. Okay, there we go. And then we'll pause there, and you can see I have maybe, not real scientific, but I have like maybe a 25. This could potentially be 30. So that's what it looks like with both coils firing. So I think that's the signal they're looking for. The thing that concerned me a little bit, and I'm not sure if this is wrong or not yet, when I go on the supply side, which is before that resistor, I'm getting the same signal. Can't make that work in my head right now, but like I said, if there's any one that knows what this thing is for, and if that's right, I appreciate the input. So there's that. Here's the signal that the PCM is sending to the coil. Looks like a 4 or 5 volt. Back probing the control side of the coil. My light in the way. So, in case anyone was interested in seeing what that looks like, that's the computer control of the coil. So if you have power coming in from this fuse, which we checked, and then it comes through this little resistor and then back out and back to the coils, I can see why I would see a voltage drop on this one, because the current flowing through here, I'm going to see a little bit of a voltage change, which I think this little component wants to see, but I don't know if I should see that same signal here or not, but it's there. So now I'm going to check my output from number 2, which goes to the TAC and then to the computer. So we'll try that. Alright, I moved my wire to terminal number 2, right there. And I go to my lab scope, and I'm still seeing like the same spacing, but that shark tooth or whatever is like really small. So I'm pretty sure the computer cannot see that, and that's why I'm not going, or I don't know what that was. That's why I'm not seeing anything. So at this point, because Hyundai has 2 of them in stock, and it's like $80 or something like that, I'm going to call for this component. The only other test really would be to check resistance between that circuit and the TAC of the computer, but if I had to short the ground, I wouldn't have 12 volts, so I don't want to even go that far. I'm just going to get the component, and then I'll show you what the after waveforms look like and see if we have our tachometer reading and see if our check engine light goes out on its own. That unfortunately will be tomorrow. Alright, I'm back in the car. Moment of truth. Gonna start it up, see if the TAC works. Yay. So there you go. There's a confirmation of that component working. So we'll go back out to the lab scope and see what the reading should look like. Alright, there's the new component. Right now I'm back probing the power feed to the ignition fail module, and I still have that signal. I'm not sure why it's there, so if Scan or Danner happens to watch this and can break out into some long dissertation of Ohm's law or something, I'd like to understand it. But on same thing on the coil feed side, I have the pretty much same signal, which is what I had before. And then if I go down and I probe the actual signal back to the computer and to the tachometer, there is the signal that's going to make all that work. The computer will now be happy. Light will probably go out on its own, but I'll just clear it and be done with it. So that's it. I appreciate you watching. Thanks.